we're going to continue our topic in inequalities, which we mentioned in part 1 and part 2. So today is about part 3, where we will be solving and graphing inequalities. All right, so this is the first inequality we have here, which is I would say one-step inequality, where you have to solve for x. So the way we solve an inequality, we basically treat it exactly the same way we treat an equation. Right. The first thing we need to look at here, we know that we need to isolate x, right? In order to isolate x, we need to get the x by itself, right? So you notice like the number next to x is 2. So whenever you are given something like that, right? Whenever you are given something like that, and you notice that there is a number next to the x that you need to isolate. You need to divide both sides by that number. And the way you do that, right, you see dividing both sides by 2. Since the number next to the x, the number you need to isolate is 2, right, you divide both sides by 2. The reason why we do that is because whenever you divide something by itself, it gives you 1. So meaning that you get rid of it. All right, so you're looking at over here, you see 2 divided by 2 will give you 1, right? You see 1x. And remember that the sign will remain the same, right? And you put the sign inequality over here, which is less than. And then you do 10 divided by 2, which is 5. Now you solve the inequality. Now the second part is so this is part 1. We can call this one over here part 1, right? Part 1 where we solve, right? So we solve. Now we need to graph. Because we already solved the inequality, now we need to graph it, which is part 2. Right? Part 2, which is graphing. Right? We are going to graph the inequality. So to graph the inequality, we did it in part 1. So remember that we have the number line here, right? It's going in both directions. And then the middle here is 0. And then there's the 1, 2, 3, 4, and then 5, and -1, -2, -3, -4, and so on. So you know that, remember when I say that it's less than, when it's less than, you know that it's going towards left. And you notice that 5 will not be included. And when it's not included, remember that we put 7, right? And 5, right? So we start at 5 and it's going to the left, meaning that x can be all the value on the left of 5, right? So this is the first example. So let's take another example. Let's do another example with, how about you try this one? Try this one. Pause the video and try this one. Okay, so the way we will solve this one, right? So we will do exactly the same thing, right? You notice that, hey, the 5 is the intruder there. We need to get rid of the 5. So to get rid of the 5, we have to divide both sides by 5, right? And then when you divide both sides by 5, you have 5 divided by 5 will give you 1. And then, you know, 1 is always there, so we don't have to put it there. So it's greater than or equal to 3, right? And then after that, you draw the number line here. You draw the number line, and then let's just put 1, 2, 3 over here, right? -3, -2, -1, 0, 1, 2, 3. And then you know that it's greater than, but will 3 be included? Will 3 be included? Right? Yes, 3 will be included because x can be 3 because it's greater than or equal to 3. Meaning that we start at 3 here, right? Which is we put a solid that, right? Remember when it's included, you put the solid that, and then since it's greater than, it's going to the right. Meaning that x can take all the value from 3 to all the value on the right, or from 3 to all the value on the right of 3, right? So this is one step. So let's do one with 3 steps. So let's do spots. Let's do C over here. So let's say that we have 3x. Let's choose a different variable. Let's put 3y and plus 3, and then greater than 5, right? So you notice that you have two numbers on the left side here, right? Two numbers on the side of X, on the side of Y. So remember that we are going to treat exactly the same way we treat an equation. To treat an equation, you notice that there are two intruders on the left, right? Which not supposed to be there. So the intruders are 3 and 3 here, yes? So the way we get rid of, to get rid of this, we need to get rid of the first one. To get rid of the first one, you notice that the sign of 3 is positive, right? If the sign of 3 is positive, you have to use the opposite sign of 3 in order to get rid of it, because if you don't do that, we will not be able to get rid of the 3. Or another way you can think about it, if you see there's an intruder on the left and you want to bring it to the right, you can just bring the number to the right and change the sign without having to say, hey, I am going to subtract both sides by 3, right? So the opposite sign of 3, the positive 3, is -3, right? Remember that whatever you do on the left side, you must also do it on the right side. So I know it's going to be -3 on the left side, right? So now what do you have? You have 3y plus 3 minus 3, right? Minus 3 over here. And then you have greater than, and then you have 5, and then you have -3. Now let's simplify. Let's simplify. So look at this carefully. We're gonna keep the 3y, right? The 3y will remain. Positive 3 minus 3 is 0, right? It's 0, so we don't have to put it there, right? And then greater than. What is 5 minus 3? 5 minus 3 is 2, right? Now, remember the steps that we've done on part 1 over here. The first question we answer here, we see we have dot forms here. So to get dot form, when you get dot form, you know what to do. So you're looking at the number next to the y, right? This is the number next to the y. And then you are going to divide both sides by that number, right? And then you have 3 divided by 3 give you 1, which is y. We don't have to put the 1. And then you have 2. We can leave it that way because it's a ratio. It's a fraction. We can leave it as a fraction, right? So now let's do it that way. So let's draw our number line. Let's say we have 0 over here. This is our number line. Let's just still put over here, we put 2 over 3. And over here, let's just put -2 over 3, right? You know, everything is there. 1 over 3, 2 over 3, and so on, right? So over here is 0. So we're looking at our number line over here. We're saying that, hey, there's a greater than. When it's greater than, you know that it is included or not included. It is not included because 2 over 3, y cannot be 2 over 3, right? And when you know it's not included, we put a circle. And now we say it's greater than. When it's greater than, meaning that it's going to the right, right? When it's going to the right here, so meaning that x can take all the value on the right of 2 over 3, and those value over there, it cannot take these value over there, right? Good. So now let's do another example. Let's do another example here. Right. So let's do x plus 6 less than 10. Right? So look at this carefully. What number do we need to get rid of here? We need to get rid of 6. In order to get rid of 6, we need to use the opposite sign of the positive. You see, the sign is positive, so we need to use the opposite sign from both sides. So what is the opposite of positive 6? The opposite of positive 6 is -6. So we have to take -6 from both sides, right? And then we can say that 6 minus 6 is 0, which means that it's canceled. And then you have x less than 10 minus 6 is 4, right? And now I can draw my number line. So I have x is less than 4, right? So x less than 4, And then I could just put over here, I could put 3, and then I put 4, negative 4 over here, and I could put 3, and then 4 over here. So we need that over here is 0. So, and then I can start at 4, right? Is 4 going to be included or not included? 4 will not be included because it cannot be 4. So I will put a circle, right? And then we notice that it says x has to be less than 4. So if x less than 4, meaning that it has to take all the value on the left of 4, right? All right, and then all the value over here, x cannot take none of the value on the right of 4 and 4. All right, thanks for watching, and I hope you enjoyed it.